What if I told you that the edge of our solar system is not empty? Far beyond Pluto, in a place so dark that the sun looks like just another star, there may be trillions of frozen objects waiting in silence. And now, James Webb has started detecting clues from that hidden region. Not a planet, not a galaxy, but a frozen archive around our own sun that may contain secrets from the birth of the solar system, and maybe even material from other stars. This is the Oort cloud. And what Webb is finding there is changing how scientists imagine our cosmic backyard. For most of human history, we had no real way to see the farthest boundary of our solar system. We knew the planets. We knew about asteroids. We discovered icy worlds beyond Neptune. But beyond all of that, scientists believed there was something much larger, much darker, and much harder to observe. A giant invisible shell surrounding the sun. A region so far away that even sunlight becomes weak. That region is called the Oort cloud. And the strange thing is, we have never directly photographed it as a whole. We only know it is there because of the objects that fall from it. Comets. Every now and then, a comet appears in the inner solar system from deep space. It swings around the sun, grows a glowing cloud around itself, sometimes forms a tail, and then disappears back into darkness. For a long time, scientists kept asking the same question: where are these comets coming from? In 1950, a Dutch astronomer named Jan Oort studied the paths of long-period comets. These are not the comets that return every few decades. These are comets that may take thousands or even millions of years to complete one orbit around the sun. Oort noticed something strange. These comets were not coming from one direction. They were arriving from all over the sky. From above the planets, from below the planets, from every possible angle. That meant their source could not be a flat ring like the asteroid belt or the Kuiper belt. It had to be something bigger, something shaped more like a sphere. So Oort proposed that the solar system is surrounded by a distant cloud of icy bodies. These objects were probably thrown outward billions of years ago by the gravity of the giant planets, especially Jupiter and Saturn. Instead of falling into the sun or escaping completely into space, they became trapped far away, moving slowly in the dark. That idea became the Oort cloud, a frozen storage room of the solar system's oldest leftovers. And if that sounds peaceful, it is not. It is one of the most extreme environments connected to our sun. The inner edge of the Oort cloud may begin hundreds of billions of miles away. Its outer edge may stretch trillions of miles into space, reaching a large part of the way toward the nearest star. Out there, the sun does not look like the sun we see from Earth. It is not bright. It is not warm. It is only a distant point of light. If you were standing on an object in the Oort cloud, the sky would be completely black. There would be no blue atmosphere, no clouds, no wind, no sound. The ground beneath your feet would be frozen harder than stone. The temperature would be close to absolute zero. And because many of those objects are small, gravity would be extremely weak. A single jump could keep you floating for minutes before you slowly came back down. Everything would feel still, silent, almost timeless. Some of these icy bodies may take millions of years to complete one orbit around the sun. Time out there moves on a scale that the human mind can barely hold. And for decades, that was the problem. The Oort cloud was too far, too cold, and too faint for us to observe directly. So astronomers had to wait. They waited for gravity to disturb one of its frozen objects. Maybe a passing star moved close enough to give it a tiny pull. Maybe the gravity of the Milky Way shifted its path. Whatever the cause, one small change could begin a journey lasting millions of years. An icy body would slowly start falling toward the sun. As it came closer, sunlight would begin to heat it. Frozen gases would escape. Dust would spread around it. A glowing coma would form, and suddenly, a hidden object from the edge of the solar system would appear in our sky as a comet. That is how we studied the Oort cloud. Not by going there, not by photographing it, but by waiting for its messengers to arrive. Then came the James Webb Space Telescope. Webb was built to see the universe in infrared light. It can look at ancient galaxies forming stars and planets around other suns. But that same power also allows it to study cold, faint objects much closer to home. One of the most important objects Webb has observed is a comet called C2014, UN 271, better known as Bernardinelli-Bernstein. At first, this comet was just a faint moving dot found in old survey images, but when scientists calculated its size, they realized they were looking at something extraordinary. The solid core of Bernardinelli-Bernstein is estimated to be around 85 miles wide. To understand how massive that is, Halley's Comet is only about 9 miles wide. Hale-Bopp, one of the most famous bright comets of modern times, was also far smaller. Bernardinelli-Bernstein is not just a comet, it is a giant frozen relic from the early solar system. And it came from the distant Oort cloud. That discovery raised a huge question. If one object this large exists out there, how many more are hiding in the dark? When Webb studied Bernardinelli-Bernstein, the comet was still extremely far from the Sun, beyond Saturn's orbit. At that distance, scientists did not expect much activity. It should have been too cold for ordinary water ice to turn into gas. But Webb detected something unexpected. Carbon dioxide was escaping from the comet. Think about that for a sec. This object had spent billions of years in the coldest, darkest region around our sun. And now, as it moved inward, it was releasing gases that had been locked inside since the solar system was young. Webb was not just observing a comet. It was reading an ancient chemical record, a message from more than 4 billion years ago. That is why Oort cloud comets are so important. The planets have changed. Earth has oceans, weather, volcanoes, continents, and life constantly reshaping it. Mars has been worn down by radiation and dust. The Moon has been hit by impacts for billions of years. Even many asteroids and comets closer to the Sun have been altered by heat and sunlight. But the Oort cloud is different. Its objects have spent most of their lives in deep freeze, far from warmth, far from sunlight, far from the violent changes that shaped the inner solar system. They are time capsules, frozen pieces of the beginning, and Webb is giving scientists a way to study what is inside them. Another important comet Webb has studied is C2017 K2 Pan-STARRS. This comet was unusual because it became active while still very far from the Sun. Normally, comets wake up as they come closer to the inner solar system. But K2 was already showing activity at a distance where many scientists expected it to remain quiet. When Webb examined the gases around it, it found chemical fingerprints of carbon monoxide, carbon dioxide, water ice, and organic compounds. Organic compounds do not mean life was found, but they are part of the chemistry connected to life. And finding them in these ancient comets suggests something powerful. The raw materials linked to life were already present before Earth existed. Before oceans, before forests, before animals, before humans, some of those ingredients were already drifting in the dark, frozen into the material that helped build our solar system. But the story gets even more interesting. The chemistry of Oort cloud comets does not always match the chemistry of comets from the Kuiper belt, the icy region beyond Neptune. This means the Oort cloud may not be a simple collection of random leftovers. It may have layers. It may have structure. It may contain objects that formed in different parts of the early solar system. Some may have formed closer to the giant planets. Some may have formed farther out in colder regions. Some may have been changed by cosmic rays over billions of years. And some may have an even stranger origin. They may not have formed around our sun at all. We already know that objects from other star systems can pass through our solar system. In 2017, astronomers discovered Oumuamua, the first confirmed interstellar object ever seen passing through our solar system. Then, in 2019, Comet 2I/Borisov became another confirmed visitor from beyond our sun. These objects came from other star systems. They passed through our neighborhood. Then they moved on. But here is the question that makes the Oort clouds so fascinating. What if some interstellar objects did not leave? What if, billions of years ago, some were captured by the sun's gravity? What if they became trapped in the Oort cloud? If that is true, then the Oort cloud may contain more than the leftovers of our own solar system. It may contain material from other stars. Actual pieces of other planetary systems, frozen around our sun, waiting in darkness. That means some comets falling toward us may carry not only the history of our solar system, but also clues from somewhere else in the galaxy. A comet in our sky could be carrying material that was born around another sun. That is not science fiction. It is a real possibility scientists are trying to understand. And it completely changes how we imagine the edge of the solar system. It is not just the end of our neighborhood. It may be a border zone, a storage place, a cosmic archive, a region where the history of our sun may be mixed with material from other stars. Most of these objects will never come close to us. They will remain out there for billions of years, moving slowly through the dark. But sometimes, gravity changes everything. A passing star gives one of them a tiny pull. The Milky Way's gravity shifts its orbit. A frozen body begins to fall inward. And after a journey that may take millions of years, it finally reaches the inner solar system. By the time we see it, the event that started its journey may be older than human civilization. That comet becomes a messenger from another age, and Webb is helping us understand the message. The telescope cannot show us the entire Oort cloud in one beautiful image. The cloud is too vast, the objects are too far apart, the signals are too weak. But Webb can study the comets that come from it, one by one. Each comet adds a new clue. One reveals ancient carbon dioxide. Another shows organic chemistry. Another may suggest a different formation region. Another may hint at material that came from outside our solar system. Together, these clues are slowly building a map. Not a normal map with roads and borders. A chemical map. A map made from light, from motion, from frozen gases, from the fingerprints of ancient matter. And in the coming years, this story may grow even bigger. New observatories are expected to discover thousands of long-period comets. Some of those comets may come from the Oort cloud. Some may become targets for Webb. And with each new observation, scientists may get closer to answering major questions. Is the inner Oort cloud different from the outer Oort cloud? Are some regions richer in carbon? Are some objects older than others? Did our sun capture material from other stars? And could some of the ingredients that helped make life possible have been delivered by objects from this distant frozen region? For most of human history, the Oort cloud was not even imaginable. Then it became an idea. Then it became a theory. Now slowly, it is becoming a real place of study. Not because we have traveled there, not because we have seen it directly, but because its messengers are arriving. And for the first time, we have a telescope powerful enough to listen. Every comet from the Oort cloud carries something with it, a piece of ancient chemistry, a memory of the early solar system, maybe even a trace of another star. The space beyond Pluto is not empty. The edge of our solar system is not silent. It is filled with frozen worlds, ancient fragments, and secrets that have been waiting billions of years to be found. The Oort cloud is not just darkness. It is a